So I have started the recording. Hello, everyone who's listening to this. I guess maybe watching as well later on. I can share my screen as well here. It's just going to be my browser, so it's not going to be super interesting. And it's like I said, it's going to be super basic. So today we're just going to cover something like what is a terminal, what is an LLM, what even is programming. Why am I even joining this session? This sounds really boring. We're going to be answering those questions today. I'll start with the last question. Why are we even here, right? So I'm not going to say anything new if you've ever programmatically connected or invoked an LLM, right? Connected through a client with an LLM. I'm not going to tell you anything new today if that's already where you're at. We will get there, though. We will get there in a couple of sessions. I can't promise how many. I feel like I should leave it a little bit flexible for myself and for the people who are joining, right? So I don't know who is going to be joining, and if most of the time, mostly some already experienced people will be joining, we might go a little bit faster, right? At the same time, if mostly absolute beginners are joining, in that case, maybe I do want to take it a little bit slow, make sure everyone is up to speed between the sessions, those kind of things, right? So also, if you have questions in between sessions about this stuff, just ping me in general. It'll be fine. Yeah, so today on the agenda is mostly just actually setting an agenda, right? So planning what the next few sessions are going to be like. I have some ideas in mind already. You can help shape them, right? So if there is something you'd really like to see for next time, we can actually do that, right? So we can tailor it to what the interests are. If you don't say anything, we're just going by what I think is interesting, which is also fine, right? So any case, thank you everyone for joining. It's really nice to actually not be talking just to myself, or at least I can pretend that I'm not talking to myself, which is really nice. Okay, so I'm thinking that today we just get everything started. So I'm presuming that you are going to have at least a PC or like with some operating system, right? So whether it's Mac or Windows or Linux, right? I'm presuming you have that with enough permissions, right? So it's not going to be a work laptop or whatever, with enough permissions to install stuff for yourself. Then I'll go over what we will be, or what I like to use, what we'll be using in some of the more hands-on parts, right? So I will give you a little bit of background, but in the first 3 or 4 or 5 sessions, I will probably not be touching anything in any mathematical depth, right? So it's really just going to be me explaining why things they are the way they are. I'll be bringing some slides when we get to the more complex stuff anyways, just so I can have some diagrams or maybe something like this, right? But we will not need a blackboard. We will not need to bring out our calculators, nothing like that. We might get there. Like I said, it depends a little bit on what our audience is and what we want. Okay, so that was already 5 minutes. I've been waffling about nothing. So let's actually get some stuff done, right? So what is a terminal, first of all? The terminal is just a way to interact with some commands and programs on your computer through a text interface, right? So that you have a nice visual interface like in this browser is really a luxury of the past, actually a long time at this point, actually, probably, but don't worry about that. Back in my day, we used to have only terminals. That's not really true. So here you can actually just invoke some commands basically, and we'll be using that to install things, right? So maybe you want to download things, and so if you look at the download for example, Visual Studio Code, there may be just something you can download here directly, but there may also be a link that you can enter into your terminal, something like this. Talking about Visual Studio Code is where we will be doing maybe some of the programming. If we do get to that, it will take at least 3 sessions, I think, before we'll get into anything that will require some programming. We'll not be doing something super algorithm heavy even in 3 or 4 sessions, but what I do want to do is at some point actually use these LLMs in code so that you can actually start building some stuff, right? So a lot of the things that we'll be doing hands-on, even in the first session, maybe even today a little bit, is not going to be in code, but that also means you're not going to be putting it out there anywhere. It's going to stay local to whatever you're doing. So to share it with the world, you want to have it, ideally you want to have it in code in some form. So that's where this comes in. Yeah. If we want to be using anything that is based on Python, I propose using UV for now. It's actually just been bought by OpenAI. So maybe we'll not be using UV for super long, or at least maybe I'll not be recommending UV for super long anymore, because OpenAI has some history, let's say. But maybe it will stay super nice. Maybe it will stay super open. Who knows? But for now, it's really great if you want to have something for Python. And so that's what we'll be using. And so this is essentially to get your environment started up, right? So if this is already a bit daunting to you, don't worry about it. We'll get to that later, maybe in the next session. But I just want to cover over the things that we'll be looking at, just so you understand. It's going to be super basic at the start, but it will probably ramp up pretty quickly towards some more serious stuff, right? So just be ready for that. If you're a complete beginner, things are probably still fine for now. But yeah, you may need to spend some time with it, to really play around with it in your own time if you want to be able to keep up as well. For next session, I was thinking that we can use something like OpenWebUI. OpenWebUI is an interface, let's say, to connect to some of the LLMs and through an API, for example. What does that mean? The API is essentially a way for programs to communicate to each other. So in this sense, this nice web interface can communicate with OpenAI compatible LLMs, essentially, right? So OpenAI has ChatGPT. So as you can see, it proposed, for example, GPT 4.1 Nano. I will be showing you how you can set this up so you can test it locally as well. So you can have this nice interface on your end. Actually, in fact, once you have UV, it's only one single command that you need to run to do this. So it's super nice. And essentially, the only thing that we'll be doing then in this interface is prompting, right? So it's prompt engineering in a sense. So it's very basic, but it'll be nice to see how actually behind the scenes these things are happening. Right, so there's also some more on, let's say, to actually deploy stuff, to host things yourself, to integrate some other things with OpenWebUI. So you can go a little bit further with it than just prompt engineering. But it's not like all the large websites use this thing to do the chat, right? So it's really just for some playing around with it. So this is what I think of as like a next session kind of thing, right? Maybe we'll get to installing it a little bit today as well. But the core idea is that we get to a point where you can run this and actually play around with prompt engineering your own chatbot or this kind of thing, right? So are there any questions before I go on? Like, let's say, are there any questions for what we're doing today or what we're doing next session? These things, or am I going too slowly? What's the vibe like? Let's say, right? So it's vibe check. Nothing special yet. People have fallen asleep. That's a bit of a shame. I'll be falling asleep soon too. All right, it's good. Okay, that's good. All right, that's nice. Then we can go on to what I plan to do. Yeah, exactly. That's great. Yeah, the point is really to just go at a slow pace, especially for today, and then slowly keep ramping it up in the next sessions. So what are we going to do after, let's say, we did some basic prompt engineering? Well, we'll be going over some more advanced stuff, right? So this can be hosting a very small model yourself. If you have a machine, so I'll be polling in chat, and if you do have a machine with a bit of a GPU inside, not for everyone, then you can host a small model yourself, actually. And you can, instead of needing to rely on OpenAI's or Google Gemini externally, you can actually talk to your own self-hosted LLM, for example, right? This is quite nice. Another thing we can do, which is already built into this thing, is something called RAG. Maybe you've heard of RAG, maybe you've never heard of RAG. Essentially, it's a way to provide new information to these models, right? And so this brings me to a nice point, I guess, also in the talk where we can talk about what even are these models, right? So you'll have Cloudflare's answer. What is an LLM? Yeah, exactly. What even is this thing, right? It's like, what is an LLM? I mean, it's a bit obscure. I don't think anybody is ever talking about this stuff, but it's like, if you are like really nerdy, like into like some deep research shit, you may have heard like of this like large language model stuff. No, actually, yeah. So this thing is now here because of one paper, and you will know the name of the paper for sure. This is the paper, right? So it's the Attention is All You Need paper. And it comes with a lot of diagrams, which you may or may not be able to understand at this point. We will get there. The core insight that you need to understand why this paper in 2017 is why less than 10 years later, everyone knows of LLMs, whereas they have probably never heard of other AI models, right? Why did this model, the transformer-based one, why that one become so huge, whereas the others are like for like real AI nerds, right? So instead of for the mainstream. At the time before this paper was released, we were doing a natural language processing. And the way we were doing natural language processing is in many different ways, right? So we were doing very basic things like counting how often a word occurs inside a specific text. We were doing things like that just to be able to understand, let's say, how we can numerically represent words in a sentence, right? So these kind of things are what we were doing. We were also using deep learning. The problem with using deep learning is that you will need to have we will need to have essentially a way to input into the model a word, probably one at a time, right? Because we are like, let's say we're reading the text into the model, and then maybe at each point it may need to be able to make some decision, right? Or it may need to, if it's going to be like generative, we may want to have the model complete the next word, right? So these things need to happen one word at a time. And the problem with having to do it one word at a time is that it's really hard to scale this up, right? Because at this word, you're waiting for the computation to be completed, and only then you can move on to the next word. Now, the Attention is All You Need paper was such a breakthrough because it showed a way where you can do this one and this one and this one, and essentially you can think of all the moving ahead chunks where you process all of it that you would normally have to do step by step. It showed a way that you could do all of it in parallel, which means that if you have a big enough machine, you can train on as much data as you have. And so that's where people started really scaling up their machines, and OpenAI started downloading data from everywhere, and OpenAI started essentially getting contracts for data centers, and they made GPT-2, right? So this is where I have to differentiate LLMs from GPT. So the LLM is essentially just, in theory, it's really just what it is, right? What it says it is. It's a large language model. It doesn't have to be based on this, right? It could have been any model, but typically GPT and LLM are used interchangeably. A GPT is a generative pre-trained transformer, so it's this architecture, and it's pre-trained, which means is that it's been training, like I said, on this huge amount of text. And it's generative in that it's trying to predict the next word, let's say, right? So it's not exactly next word. Most of you probably know this already, but yeah. So OpenAI started training this GPT-1. Perfect. So this was around 2018, 2017, right? So it's following Google's attention is all you need paper. They were like, okay, so we can do that to train nice language model that predicts the next token. Okay, sure. Then they were like, okay, but what happens because these things allow you to train in parallel, right? Which hasn't happened before. What just happens if we add more data and we add more compute? Then we get GPT-2, and this is February 2019, so it happened like next year, and it's really just a direct scale up, right? So let's say almost no new ideas. It's not completely true, but yeah. Then they saw that actually its capabilities and how frequently it makes, like, let's say completely makes up stuff or breaks down. It was just much better compared to GPT-1, right? So it seemed like it's not just a direct scale up, it's also a direct improvement, almost linearly so, right? So that was really impressive, and this is where they were like, okay, so maybe we can keep doing this. And so they made GPT-3, and this one was, the previous ones were like, as far as I'm concerned, they were close to proper research, right? GPT-1 especially, GPT-2 not so interesting from an academic perspective, right? As it is really just a scale up, but let's say it's still open. It's still there was some stuff published as well. So then they were like, okay, maybe we can actually make this commercial. So in a already preparing for what later became known as Web GPT and then renamed ChatGPT. They made this GPT-3 was closed source, if I remember correctly. I think 3, yeah, exactly. Microsoft announced that it had licensed GPT-3 exclusively, right? So here they really shifted to a completely different business model, let's say, right? So I'm giving a bit of context because I think this kind of development in the field is quite interesting to understand the incentives, let's say, as to why and how these models are being made, which can also explain part of why it's good at certain things and why it's bad at certain things. So this is why I think it's relevant to go over a little bit of the history of this stuff. As you see, you don't really need a lot of understanding of deep learning to learn this history, right? Like, I've not really touched onto any deep learning specifics, so maybe that frustrates you if you wanted to get into the maths. Maybe it's pleasing if you were a bit daunted by the whole complexity behind actually these models, right? So they're not necessarily super simple, but we will also pull that apart in a couple of sessions probably. Yeah, so this is like where we get to GPT-3 and where you get ChatGPT being the largest or one of the fastest selling apps or growing apps in history. So it's like time to 1 million, right? So this is like users. Yeah. So here you see like really this kind of exponential curve, right, where things have really moved like exponentially ahead, in where Netflix in 1999, really Netflix started in 1999. That's crazy to me, man. Okay, but yeah, 1999. Netflix started, took them 3.5 years to reach 1 million users across all of these, like, let's say, different companies and products. Really, 1 million users does not really mean the same thing, right? Like if it's like paid for, like Airbnb, you have to pay to use it. Netflix, you have to pay to use it. Whereas Instagram, you are the product, right, to the advertisers. So it's not really the same thing, but yeah. In any case, you see that really like over the years, it's become exponentially faster to ship your app and to reach 1 million users. But really, this jump between Instagram in 2.5 months to ChatGPT in just 5 days, this is absolutely ludicrous to me. But this explains why it gains so much media attention as well, right? So like, if you're an investor, you pay attention to this, right? Of course, you pay attention to this. So that showed like really in 22, they showed strong, I guess, market interest to investors. I think to regular users, my feeling was that it was like a real roller coaster of things, where a lot of people had moments where they were like, wow, this is the most insane shit ever, to like, holy shit, it's so bad, I'm never going to use this again, right? So you have these kind of ups and downs. I think a lot of people experience that. Either way, these are essentially from GPT-3 onwards. They were not super transparent anymore. OpenAI wasn't super transparent anymore in how they trained their models, or they became less and less transparent at least. So what GPT 5 point something is today, nobody knows. But we do know more and more techniques and tricks to train these large language models. We have techniques to fine tune them. We have techniques to give them new information, even without having to train them again, so they can output text as if they had learned this, right? So we have all these kind of different techniques, and we'll be going over that in some next sessions as well. All right, but yeah, now back to what is this LLM, right? So in a sense, it's a deep learning model, but it is so large that it kind of breaks a lot of our intuitions, I would say. If you had been a deep learning practitioner like me, in the field already around the time that this emerged, I think you would have been quite caught off guard by, I guess, how good these models are, first of all, but also, I guess, how it breaks a lot of established or conventional wisdom at the time, right? So we knew that we could make large models, but typically, even for large models, there is a limit to how deep we can make them. We run into some problems, and these LLMs, they don't really seem to have that issue, especially when we have enough data, right? So data was king. Nowadays, we are running into a completely different problem. Actually, we do have a lot of data, but the amount of quality data is very limited. So maybe I can see AI learning from AI content. Yes. So here we already have in 23, right? So see how early like people were already like on this. Here we already see like models that are training now not just on human data, right? But they are training on AI generated text as well, right? So nowadays we have a very different problem. At the start, we were like, okay, so we need to get more and more data into these models. And now I think the large companies like OpenAI, Google, Anthropic, they have scraped every last piece of human generated text that they could find. And at this point, they are probably like, they have databases that are reflecting the open internet probably as we know it. And which means that if they keep doing this, by now there is so much AI generated content that if they keep doing this, they'll be scraping AI generated content as well. And actually, training a model on AI generated text is actually quite bad for the model. So this has the derogatory term like AI inbreeding, right? You see this also in the image generation part, where if an image generating model is trained on other AI generated images, it will slowly start to introduce this yellowish tint more and more often, right? So everything becomes a bit more sepia tinted, or piss tinted, I guess, as people say it. Thank you. You guys are so kind to me. All right. So so this is a new problem of the past few years, I would say. So first it was really like, how can we build the biggest data center and build the biggest database so that we can train these models, because if we do this, we know that we will get the best model. And I think the hype was kind of that there is no end in sight, right? So these things, they were hoping that the capacity, the capabilities of these models scale linearly, and they keep scaling. I think we're starting to plateau a little bit, but whether this is because of the scaling law not holding up or because more and more AI generated text is making it into the training data, that is not entirely certain, of course, right? So there's a lot happening in this space. A lot of it will start to make a lot more sense once we are actually able to get into the more technical details of these models. But for now, we're not going that in depth, right? So we're just, happening for the last year. Yeah, I agree. I think actually people have been feeling a bit upset with maybe the latest models as well, right? So people are already feeling that it's good on the benchmarks, right? So we can go to the benchmarks, right? So these latest models, they are doing really well on maybe common tasks, on benchmarks, even on just actual human input, right? So they seem to be doing really well for this. But then as soon as you ask something very specific, maybe you're doing some more complex reasoning based on some theoretical thing or based on some niche real life thing that it should know about, but may not really be reasoning about all that well. In this case, people have reported that these latest models are sometimes a little bit worse than older models, which is interesting, right? So so we'll have to see exactly how these things will scale into the rest of 26, maybe going into 27 next year as well. Whether these things keep getting better, they have definitely been getting better for the past years, or whether we will need a different approach, right? So no one can say at the moment, I would say. But these LLMs, as you can see, there are so many different providers, right? So you have Anthropic at this point being at the head of this leaderboard. What is this leaderboard, either way? Actually, this leaderboard is a human-based leaderboard. So people actually go to this website, and you can go to this website as well. It's arena.ai, and you can do a battle mode, for example. Then we can just ask a question. What question should we ask of the anonymous LLMs, right? So these LLMs, I mean, they want to stay anonymous for obvious reasons, right? They are sometimes outputting slop. If I was putting that much slop on the internet, I wouldn't want to be like known myself either, right? So they want to stay anonymous, but we do have we do need to give a question to them. So what are you guys thinking? What should we ask of the LLM? Something maybe not too complex, but maybe interesting enough that we can see a difference between, let's say, a bad model and a good model, right? So, what's the matrix representation of a sesquilinear map? Maybe a math question. I see. So I will do that. It sounds mathy at least, right? So that's good enough. Maybe let's go with Keb's question. That sounds good. Yeah. And so when you're doing these things, right, always know also when we're doing the Olama stuff later, right, where you have set up the web interface, know that as long as you're going through an API, everything is being sent to these vendors, right? So if you're using OpenAI's GPT 4.1 Nano, it will be sent to OpenAI. If you're using Gemini, it will be sent to Google. In this case, it'll be sent to the owners of these two anonymous models, right? So I'll have to agree to that. I was a very fast reader. I read all of the privacy and terms of conditions and those kind of things. Trust me. So they're generating. I don't know if they purposefully slow them down or not to be at the same speed, right? So like maybe if one is super fast and the other is slow, that will give it away already which one is maybe the better model or the bigger model at least. Though I must say, Keb, you kind of want to be able to distinguish the answer from these two. So you need to know the answer to this yourself. This is one of the most right. So as you can see, some models really love making you feel validated, right? So right away we start with one model that really loves to please you already. But it's interesting. This bit is interesting. I mean, really, I am not going to be able to evaluate this question. I'll be honest. They're using the same model. What is this? But they could be right. So in your example, you may be matched up with two different versions of Quen, right? So yeah, exactly. So that could be happening here as well. They could be from the same vendor, from the same company, but maybe just one is older or one is larger, right? So same generation, but one's just larger, one is smaller. Okay, so they both gave us some answer. I'll leave it to Keb to decide whether this is a satisfying answer. Yeah, is it reversed? Represented by matrix M, whose entries are the value of the form. Yeah, so there we go. Special cases. Yeah, this is far outside of anything that I've worked with. So in that case, which one of these two assistants are better? Are you both happy with both answers? Just from a cursory look, I would say I like both answers, but that's without me understanding anything, so that doesn't say much, right? Yeah, so let's just say both are good, let's say. Okay. So do I get to see who is who? Okay, so one is Minimax. So Minimax is an interesting one, I guess, because let's open this one in a different window. Minimax is an up-and-coming one, I think, gaining more and more popularity for being... I think this one was also open. I don't remember, actually. I don't follow the news that well. But yeah, Minimax is really up-and-coming. People seem to like that it's around, except for Anthropic. Anthropic doesn't like that Minimax is around. Because this one I've not heard of. Yeah, Minimax, yeah, 2.7 is the latest one. It seems to be doing quite well as well. That's really cool. It's a pre-release one as well. Yeah. So do we find the other one? So 2.5, this is what we found here, right? So you can see it's quite high up, right? In the grand scheme of things, it's already quite high up as well. And it's nice because it's under a modified MIT, which is quite nice. This is, I think, part of why people like it. I don't see the other model, so it seems to be doing a little bit worse. Maybe I should search for it. Doesn't see it on this page. It's not on this page. So that one I don't know. I have to Google this one. Okay, pretty cool, but doesn't really tell me much. Okay, so this I'll leave this as an exercise to the reader, let's say. Okay. Let's go back to the overall leaderboard. As you can see, the performance of these models across different tasks is not the same, right? So we see Claude being quite strong at coding. We see actually at vision-related tasks that Gemini is doing better. And this mimics my personal experience, where when we are working with some of our partners, we get different use cases. In some cases, they already have a contract with some vendor, and so we just use what they come with. But if they don't have this, we also end up needing to evaluate for their task, for their specific task, what model works best. And it's not always the same one, right? So very often we end up with a different model just based on which one is performing best on the task. There are some rules of thumb, right? So like for vision or multimodality, Gemini seems to be doing quite good lately. I think people are quite happy with the Quen embedding model for RAG, for example, right? So this, I'll get into it at the moment, but this is one example just to give that. Wow, this was just one example, but yeah. So this is one leaderboard where you can compare some of the models to see maybe which one suits your use case the best. Okay, so then in the last few parts, let's have a look at what we'll be going towards in maybe 2 or 3 sessions after this one. So we will be able to do some RAG, which is, as I explained before, being able to give new information based on some existing documents or something like this. Once we have done that, I should probably say that we need to have some programming background. So maybe if there's enough interest, I'll do a small session just to introduce some programming. But really, this is an entire course or several courses worth of material, so I'll not be able to cover it in the depth that it really deserves. You will need some coding experience if we do go towards this, and this is the agent development kit from Google. There are many other kits, but essentially I want to be going towards agentified AI. Agentified AI is, first of all, it's a big hype, right? So it's like 2026 year of agentic AI. If you see this, yeah, you'll get this in on LinkedIn, right? You'll get this on YouTube videos. It's really like a big thing. Companies seem to want this year to be the year of agentic AI, and it's really just hype for the most part. I want to say, but there is something to it. If you are coming from a software development background, you'll know that having, let's say, one large chunk of code, no functions, no separation, whatever, if you have a code base like this, if you change any small thing, it will really affect the rest of the code as well, right? And so you cannot easily expand on your old code. This is what we know as also a spaghetti code, for example, right? So when things are affecting and interacting with things all throughout the code, you have spaghetti code. Doing proper separation of functions in your code base is the trick, let's say, towards writing more scalable code. Agentic AI is a bit like that for LLM calls, where instead of having one huge spaghetti LLM call, you're separating out your tasks across different individual LLM calls. That's really it. So that's agentic AI, let's say, and that's also why it's a bit of a hype, right? Let's say I'm programming and I'm writing bad code. And then now in 2027, I'm deciding to write better, more scalable code. Is now 2027 suddenly the year of modular code? Is 2027 the year of separation of concerns? I mean, of course not. It's just I'm just going to write some better code. So in some ways, it's just some nicer LLM calls, right? You can constrain these individually small LLM calls also a little bit better, right? So instead of having one LLM that needs to do everything and has to have access to everything, you can just say one LLM just needs to parse phone numbers, right? And so it's supposed to output some numbers, which is much easier to check. We got a question in chat about the benchmarks, right? So this is a human-based leaderboard. So what we just did here, this contributes to the leaderboard probably. There are many other benchmarks, right? So you can have a benchmark with some one popular benchmark, let's say, is called the Humanities Last Exam. This is a popular benchmark as well. And so there are a lot of questions in this one. There we go. And some of these questions, I don't know exactly how all of them are evaluated, because I know that some of them are a bit complex. But a lot of the questions are in the format that they can be quite easily validated, let's say, by the answer. But the questions themselves, as you can see, are actually just like really tough. Like, I think it's called Humanity's Last Exam because the questions are tough. They are from subject experts, right? So like these are people that are definitely much smarter than me on their subject of expertise, possibly just smarter than me, and quite possibly just smarter than me in general. From great many institutions across many different countries. That is really cool, actually. That's not just from the largest institutions. So that's cool. The issue is that this has been out now for a while. They started on this for a while ago, right? So they started in like 24, and it's now 1.5 years later. The issue with that has been out for a while is that answers to this stuff is also going to be in the data that they scrape, right? So if the answer to this stuff is inside of the data that they're scraping to train these models, how good is it going? How representative of the actual performance of this model is it actually going to be? So somehow, when you're training your new model, if you want to be testing your model in a fair way, you don't want to put the answer to these questions inside your training data, right? It's going to be able to know it, at least to some extent. So perhaps they do this. Ideally, they do this because, of course, the answers to these are ideally like kept like private, right? So they keep a set of held out questions to which even the answers are not known. So this is one way to prevent that from happening. But still, if they talk to each other, if there is any leakage whatsoever, it will be a bit biased, right? And even if you never see these private questions, right, you can see which models do better, and just based on that, guess that maybe there are more coding questions, let's say, in the held out set. Maybe you can guess that there are more history questions, something like this, right? So whether this benchmark will remain like really representative, let's say, of the actual performance of these models, that remains a bit to be seen. Typically, we see that the older the benchmark is, the less representative it is of the actual performance because of this sort of optimization by these companies to do well. There's another really nice website. It's for image generation. Generate a 9-pointed star. Image generating benchmark. Yeah, I don't know if it's here actually. I don't know how to find it off the top of my head. I'll find this later. But essentially, like, a 9-pointed star is quite rare in the database. And so, because it's so rare, and other types of stars are so common, these image generators actually fail to do this quite simple task. Actually, very often nowadays, it's not so bad anymore. But this is another type of test, and there's been a benchmark also based on this that slowly, I feel like, got optimized by the model vendors. Yep. So this is just let's say what is out there in the wild, right? So if you hear the news, you know of these companies. Now you understand a little bit better where they're all coming from, why they are investing so much, right? So you understand now, I guess, that they are investing because of this kind of a bet, right? The bet that it will keep going up, line go up. It's also that you see this now in many different products. You see it really shoehorned in when it's like not all that good, right? Like you see it on WhatsApp, you see it on any random website. And the reason is that everyone kind of wants these. Everyone wants these models inside. The reason for that is that if the models do get better, you already have a product that will now benefit from this much better model, right? So it's not that all these companies believe that their product or their service is so much better because of these current models. It's that they believe that these models will keep getting better, and when they do, they will have an amazing AI-based product, right? So this is kind of why there is like so much LLMs and image generation shoehorned into anything. It's not because it's so good in all these cases, but it's because when it does get so good, they are ready for it, right? So the question is, does it mean you optimize for out of distribution sampling, where maybe my AI image gen task is very well contained within the training samples? Yeah, so ideally we would have a way to do this, right? But it's hard to do this because especially the more AI generated content there is online, AI generated content is typically less creative, let's say, less diverse than human generated content, and so it's biasing these models even further towards commonly seen things. It's going to be very hard to do indeed this kind of learning, and so you really need to control for spending extra time out of distribution to do this. I don't know exactly what is currently going on in image generation, how much of this they already do, how effective all of this is in combating this kind of stuff. I know that when it comes to this AI inbreeding, that a little bit of inbreeding is already enough to really damage it. So I wonder if out of distribution sampling can really fix for that. Yeah, exactly. Yeah, so that's fair. Like diagrams and flowcharts are in distribution, but they are a bit more complex, I guess. Now Banana 2 is a hype on images. Yeah, people seem to like Nano Banana, right? So yeah, image generation is it's in a surprisingly good space, I guess. We'll not be covering actually. I'm not planning on covering image generation for a long time. But if this is something that you guys like, I in a sense I like image generation maybe even less. I don't know. It's I'm a bit conflicted here, right? But I like image generation a bit less since it's harder. I feel like for artists to use this in a constructive manner. Does that make sense? So I feel like for writers and coders and all these kind of things, I think it's easy to use LLMs in a way that is constructive to your workflow. And when you're an artist, I feel like bye bye, thank you for being here. When you are an artist, essentially having a fully completed, let's say, final output is not really conductive when you're used to working like with layers in Photoshop, right? And these kind of things. So you still have to quite heavily edit it to get a somewhat usable asset, let's say, to work with. Or if you want to use it as, let's say, a pose study, it's actually famously inaccurate at like human anatomy and these kind of things, right? So it's getting quite a lot better. So it's really good actually at hands already, right? So image generation. So it's really good for a lot of things already. But the way it's being used, yeah, I agree. I think for now we really have to rely from the human touch. I do hope that we can actually get some tools that artists actually benefit from, right? Instead of that they suffer from. So I do hope that maybe one day we will see a form of AI that actually makes them happy that AI exists instead of gets everyone banned from AI art communities if you have like the AI tag or something like this. Okay, so this is image generation we were talking about. Of course, there's also video generation, but for now, wait, hold up, one question. It's not an artist tool. Users who aren't very talented or very creative. Image gen as it stands. Yeah, you could argue for that. Similarly, you can argue for example, in game development, especially early on in the game development, you're working with a lot of just some free assets typically because you're going to be reusing um, uh, and rewriting some of the parts of your game. So you don't want it to be the final version, right? So people might make this case. I don't know if I'm convinced because there are already so many, like in the case, for example, your code base documentation, there are so many free icons and something like this um, that you can already use for your documentation, for example, that exist that you don't I don't think you need to generate it better, right? So I think you can actually just, if you can search it better, that's already much better. So there are some AI tools that help you with just searching the best free asset, for example, to use in your thing. And it doesn't have to be an AI generated asset. It could just be like Creative Commons, right? Um, so this is already, to me, it's a lot better actually. It's the same for music samples. So if you're doing YouTube videos or something like this, you want to use freely licensed sound effects and music blips. So sometimes maybe what these kind of creators need is not to have music generation. They just need to be able to search these things better, right? So this is why I'm not really convinced on that. How does agentic AI differ? Yeah, so let's get back to agentic AI. I love that question. Thank you so much. Yeah, so we're going away now from the whole generative art discussion, and we're going back towards the more text-based thing. We will touch on multimodality as well in due time. No worries. But let's go to agentic AI. So after we have been doing your first prompt engineering, your first chatbot, your first RAG. In that case, I want to start on touching on agentic. As I mentioned before, but I'll repeat it just in the case. Agentic is a way to essentially separate your tasks into different LLM calls. So rather than having one huge LLM call that maybe runs out of context length, although nowadays context length are really long, so you can put in whole books, let's say. But just for the sake of argument, you can split up the context a little bit and give each agent only a small and precise task. This not only allows you to give different permissions to the different agents, but also it allows you to do things like using very small and cheap and maybe even free models to solve a problem that normally would require quite an advanced model, right? An expensive model to do this. So this is why the agentic AI is quite nice. And I recommend using it for some projects. I definitely don't recommend using it for all projects. Recently, actually, I was doing a project with a partner where I was asked to make something agentic, right? I mean, coming from the top, we want to do more agentic stuff. And we were working with something agentic, and in the end, we went back actually towards just one large LLM call, ironically. So the agentic version is still going to be around. It's still going to have its own use case, but it's not like it's going to be replacing everything per se, because the models, the LLM models, keep getting better. And so what you can do in a single LLM call also keeps getting better. Yeah, that's kind of how you can think about it. And also, of course, if you have it separated out, you can test your agents separately as well. So if you make changes to one agent, this will not really affect the other agents all that much. But if you have one large LLM call and you change the prompt, you don't know how that's actually going to affect the output from this model, right? So this is also a nice way. So in essence, it will make LLM prompt engineering and LLM engineering, let's say, it will make it feel a little bit more like software development. So this is why I think we like, or why we sometimes like using agents. Now, what are all these things? What are called MCP? What are things called actor to actor? What are skills? What are tools? All of these buzzwords are being thrown around. They are all, let's say, ways of changing how these LLMs are being interacted with, right? So agentic AI is already one way in which you split up, let's say, the prompts and the tasks that you would have the LLM taken care of. The tools is a way to tell this LLM, if you output a certain thing, we will, for you, make a call to Google or make a call to some external thing and give you back the result from that thing, right? So a tool call isn't something that it uses. It's just instructed that if you output a certain keyword, we will execute this tool for you, right? So let's give it a calculator tool. Now, if the LLM outputs calculator colon number 1, number 2, then actually my program intercepts that. It executes the calculator call, gives the number back to the LLM, and then the LLM can use the output of this tool, in this case the calculator, in its output. So this is essentially a way to cheat having actual external tools inside the LLM, because of course this LLM can only output words or tokens, and so you kind of have to spin up a way to connect that to your LLM. There are better ways to do this. There are more exact ways of doing this. We can get into that later. But essentially what you can see is they're all ways of connecting things based on what we give to the LLM, right? Compared to what we take out of the LLM. And we're phrasing all of that. So MCP, for example, is just one way of providing, let's say, these tools to the model, right? A2A, actor to actor, is one way to structure output from one of these LLMs into the input of another LLM, for example, right? So all of these buzzwords that you see thrown around are essentially just ways to do these kind of interactions. And it's so volatile at the moment, with a new buzzword being created, like let's say every 2 months, every 3 months, because there's not really settled on best practice, for two reasons. First of all, a lot of people have different use cases, and so different tools are just being developed for that. But second of all, these models also, just as I said, they keep getting better. They keep having different capacities, and so the structure that you need to do around it also changes, right? So this is why I also don't recommend getting like too attached to, let's say, if we do go into ADK, Agent Development Kit from Google, for your agent development, don't get too attached to it. Maybe by next year, nobody will like using ADK anymore, and we'll instead be using LangGraph or LangChain or some other way around, right? So there are different ones here. Okay, that was the full hour. I want to be wrapping up. So for next time, we will be actually doing hands-on some of this. I don't know how much, because I'll also be spending some more time on the background of what's actually happening with this LLM, but I think we can go into some hands-on after the first half hour or something like this. So that's the next session. We'll be doing that in 2 weeks, I think 2 weeks and a few days. I don't know for the exact time yet. I'll create a specific role for this one, and yeah, you'll be able to see that in chat. Then this is for the next session. Then I'll be explaining a little bit more, maybe on programming, maybe on different things. And then we will slowly go towards agentic AI as well. So over the course of 2 or 3 sessions, hopefully we'll go to here as well. Okay, that's it for today. I hope that even though it was like super slow, super low level, no programming whatsoever, I hope it was still interesting. You at least learned a small new thing, or many small new things. And yeah, next time we will go a little bit more in depth. So hope that will be a bit nicer. Next time, I think it'll be a different time, different day, different time zone. I'm thinking actually of keeping the exact time flexible, because it's a bit more fair to the different people, right? So not everyone that wanted to join today could join today. And so it's a bit annoying, but maybe we'll actually have it at different times every time. Yeah, so we'll see how far we'll get, how much programming we'll need. If there's a large demand for this, I will make sure that people are able to keep up even if you have no programming experience, right? So don't worry too much about that. Okay, I'll stop the recording. Indeed, it's been recorded.